All right, welcome back. In this video, we're going to be looking at frequency and frequency tables. So this is section 1.3, video B. All right, so frequency, relative frequency and cumulative relative frequency, and we're going to be looking at these tables and constructing those tables. So frequency is just the number of times something occurs. And relative frequency is the same thing except it's a ratio, so fraction or proportion of our values. The cumulative relative frequency is just the sum up to and including that point. And the cumulative, here they just have a quick note, the cumulative relative frequency may not be 1, just because there might be a little bit of a rounding issue along the way. We'll talk a little more about that in a moment. So here we go. Here's an example. We have what do we have? Inches of 100 male semi-pro soccer players, their heights. And this looks like it's a normally distributed function with the middle height being right around this 65, 67. And so here we have the number of players, and that's pretty self-explanatory. You can see the total adds to 100 because people can't be in more than one category. Relative frequency, to get this, you take that part over the whole. So 5 over 100 gives us 0.05. If we wanted to convert that into a percent, we would multiply that by 100 to take us to 5%. And then all of those add up to 100 or 1, but 100%. And then the cumulative relative frequency, that's just, that's up to and including that point. So for example, this little section here, 61.95 to the next part, that's the 3% or 0.03 in that category, plus the 1 before it. So that takes us to 8% of the players have a height 63.95 inches or less. Okay, and so that's kind of handy because it gives us the sum up to that point. We don't have to add up all those all the time. And that's what this is about: frequency, relative frequency, cumulative relative frequency. Okay, and here we go. We're going to be using this table to answer some questions. So lots of examples. Good news, we're finally into some calculations. So there's not a lot of vocabulary, but there is more mathematics here, but it's just adding, subtracting, and looking at percentages. So find the percentage of heights that are less than 65.95. All right, so we go to our table, 65.95, and we know there's 0.23. And then I multiply that by 100. So bring that decimal 2 spots to the right. So 23% of players are less than 65.95. Pretty straightforward. Next one, use the heights. Okay, use that table again. The percentage of heights that are between 67.95 and 71.95. All right, so 61.95 to, or sorry, 67.95 to 71.95. So we're looking here to here. So 17% and 12%, adding that together is what, 29%? There we go, 29% percentage of heights between 67 and 73. So you kind of get how this is going, 67 and 73. So we're looking at these 3 in here. So we just did those two, 29 plus 7%, so 36%. Percentage of heights that are more than 65.95. All right, so more than 65.95 is adding up these, or adding up these here. And if you want to do a little short, you could do that, but a little shortcut is to, I know this all adds up to 1. So if I want to look above 65.95, I could also take the total 1 and subtract below it. So I know 23% are shorter than that. So if I subtract the 23% from the 100%, I end up with, what's that, 77%. So it just saves a little bit of time there. Number of players in the sample who are between 61.95 and 71.25. Okay, so that's just number of players, not percent. So between here and here. So boom, 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 I add that up. 18, 58, 58 plus 29, what's that, 87? Yeah. What kind of data are the heights? The heights are quantitative because they're numerical, And then are they discrete or continuous? They are not discrete because we have decimals here, so they're continuous. And describe how you'd gather this data, the heights, so that the characteristics of all, so that the data, oh, can't quite see it there. Data, okay, so how would you collect the heights so the data is a good set of data? So one thing you could do is just give each player on the team a random number and then poll maybe 3 people from each team. And that would give you a smaller set from the total. Okay. Or it depends how big the league is. You could just take everybody if the league isn't too big. So that's it. Here we have some more examples in the book, frequency tables. I'll let you kind of look over those. I'm not going to go through all of them. Here we have just been given the frequency table, and they give us the total, and we need to create the relative frequency and then the cumulative. And so we could go ahead and bring that into an Excel, or we could just try to answer the question. So frequency of deaths measured 2006 to 2009. So boom, we just add up 2006 to 2009. Percentage of deaths occurring after 2009. So that's everything after 2009 divided by the total. So we take all those 3 divided by the total. That's our decimal. Then we multiply that by 100 to turn it into a percent. Relative frequency of deaths that occurred in 2003 or earlier. So 2003 or earlier, we take those, add those divided by the total, but we don't turn that into a percent because they just want the relative frequency. Percentage of deaths that occurred in 2004. So 2004, we take this number over the total and then multiply it by 100 to get the percent. What kind of data are the numbers of deaths? So these are quantitative data, and they are discrete because you can't have decimals related to deaths. So quantitative, discrete. And the Richter scale is used to create the energy produced by an earthquake. Here are some example scale numbers. What kind of data is this? This is quantitative, and it's going down to the decimals. So quantitative, continuous. Okay. All right, so we have more examples. And I am going to take you to your assignment now. So for this assignment, we are, let me find it, going to be using the textbook. And so this is the 1.3 assignment, and I'll put the page number on here as well, but I added in our tables. So you need to make a copy of this and then fill in the table. So we have 50 part-time students. Here are the frequencies. So 30, 15, you need to figure out what would go in there. Then calculate your relative frequencies, calculate your cumulatives, and then answer those questions. So this table is partially filled in also. Then this table has some errors in the table. So you'll need to go back in and fix those errors and then answer those questions. And using that data. And that's that assignment. Pretty straightforward. All right. That's it for now.